Alright, so now I'm going to show you how to derive a cubic polynomial in terms of z, the compressibility factor, starting with a generic equation of state. So our first step is we want z on the left side of the equation, so I'm going to multiply both sides by v over rt, because that'll give us on this left side pressure times volume over r times temperature, which is z. And then we're just going to multiply this by the same thing. And so we will have z equals r t, which will cancel out. Which will cancel out with the rt over here. So we'll just have v in the numerator over v minus b, minus, we'll have a times v over rt times v minus epsilon beta times v minus sigma beta. So what I'm going to do next is I'm going to factor out v from the bottom of this equation. So we'll have 2 over here and 1 over here, and it'll cancel out with the volumes in the numerator and start to clean up the expression a little bit. So this is equal to the same as v over v times the quantity of 1 minus b over v minus a times v over r t v squared times 1 minus epsilon b over v times, I'll just write it over here, 1 minus sigma b over v. So I just pulled out a v from both of these and here, because then it'll cancel here and here, and then one of the ones in the denominator will cancel here and here. So now we can rewrite the equation. This will be 1 over 1 minus b over v minus a over v r t times 1 minus epsilon beta over v times 1 minus sigma beta over v. So now I'm going to rearrange this equation up here and set it equal to volume, and then I'll be able to plug that value in for the volumes down here. So rearranging the equation, the volume will be equal to gas constant R times the temperature times Z over P. And so then I'll plug it in here, 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 and here. So we'll rewrite this. Z will be 1 over 1 minus B times pressure over R times the temperature times Z, minus, we'll have A in the numerator, plugging it in for this B, times P over, we'll have an R from this expression and the R from the numerator here, so it'll be R squared. Same with the T's, a T here and a T here, so it'll be T squared times Z, that's in the numerator, and then we will have 1 minus epsilon beta times the pressure, and then in the denominator be R, T, and Z. And then similarly we'll have sigma times B times P over R, T, Z. So now I have these equations. This is the equation for beta, and this is the equation for Q, and I'm going to be able to substitute those in and continue to clean this up. So if you see, beta is BP over RT, so I have beta here, I have beta here, and I have beta here. And then you can rewrite this top part, because we'll be able to substitute Q and beta into here. just have to manipulate it a little bit. So if we rewrite this as A over RT times P over RT times 1 over Z. This left side of the equation is just Q times B, because if you multiply this equation by B, this will cancel out of the numerator, so you'll just have A over T. This can be rewritten as beta divided by B, because we just have the pressure, gas constant R, and temperature, so it would be beta over B. And then we still have 1 over Z. So in this case, both of the B's will cancel out, and so we'll just be left with Q times beta times Z. And so this gets plugged in up here. So now I'm going to rewrite this equation again with beta and Q substituted in. So we have Z equals 1 over 1 minus beta over Z minus this numerator is Q beta. I messed up over here. It has to be, this will be over Z, because Z will be in the denominator. So it'll be Q times beta over Z from here times 1 minus epsilon beta over Z times 1 minus sigma beta over Z. So now if you notice, we have kind of Z in the denominator of, I guess, the bottom part of this equation. And so to get rid of that, I'm going to multiply both sides by 1 over Z. And that'll kind of clean this up. So our equation will then be, this left side will become 1 equals 1 over 1 minus beta minus Q beta. This Z will cancel out one of these. This Z will cancel out one of these. And so we'll be left with 1 minus epsilon beta times 1 minus sigma beta in this denominator. And then, camera, from here we can get a common denominator and begin to group our like terms. So once we get a common denominator, we'll multiply by this, which is this times this. So we'll have that on the left side, so it'll be 1 minus beta. And then I'm just going to go ahead and multiply this out, which will give us, oh, I made a mistake. These should be Z's. This should be Z as well, because we're multiplying by Z in the denominator here, and here, and here. So this will be Z minus beta times Z squared plus Z squared minus epsilon plus sigma times beta Z plus epsilon sigma beta squared, and that will be equal to, this will just become this denominator because it's 1 times the denominator. This will cancel out, and so it will be Z squared minus epsilon plus sigma beta times Z plus sigma times epsilon beta squared, and then this will just be minus, come over here, Q times beta times Z minus beta. Alright, and then from here we can start to group our like terms and rewrite our equation. So I'm going to do it, I'll rewrite this down here and kind of use this open space to group our like terms. So minus, rewrite that, which was q beta times z minus beta. And we're going to move everything over to this side of the equation and group it by terms. So we'll have our z cubed terms, we'll have our z squared terms, we'll have z terms, and then our constant terms. So we'll have z times z squared, so we'll have 1z cubed, z times this quantity, which will give us a negative epsilon plus sigma times beta beta z squared, and then we'll have z times this, which will give us epsilon sigma beta squared, and then negative beta times z squared will give us negative beta in the z squared, and then it will be a positive epsilon plus sigma beta squared z, and then we will have a negative epsilon sigma beta cubed for our constant term. So that's this side of the equation. Now we're going to move this over. So we'll have z, or we'll have a negative 1z squared minus, this will be plus since we'll move it over. So we'll have epsilon plus sigma times beta as a z term. This will be moved over, so it'll be negative epsilon sigma beta squared. Sigma beta squared. And then we just have this this last quantity to work out, so it will be negative q times b times z, so it'll be moved over, so we'll have a positive q beta, and then we'll have a positive q beta squared, which we've moved over, so it'll be a negative q beta squared. So now I'm going to get rid of this bottom equation since we have all of our terms, and I need room to write our final expression. So the final expression with all of our terms grouped and onto the other side will be z cubed plus all of our z squared terms, so negative epsilon plus sigma times beta minus 1 times z squared plus all of our z terms, epsilon sigma beta squared plus epsilon plus sigma beta squared plus epsilon plus sigma beta plus q times beta, and these are all z terms, and then we just have our constants. So we'll have plus negative epsilon sigma beta cubed minus epsilon sigma beta squared minus q beta squared. And so this is our final equation,